Hey there, my name's Gary Sims and this is Gary Explains. Now, most microcontroller boards, whether they're Arduino, Mbed OS, FreeRTOS or whatever, use the C programming language. Now, C is a very, very powerful programming language, and I do have a couple of tutorials here on this channel about the C programming language. However, it can be hard for beginner programmers to get into. Now, there are some microcontroller boards that can be controlled using other programming languages besides C. For example, the BBC Microbit can use JavaScript. And what I have here is the Adafruit Trinket M0. Now, it's got a Cortex-M0 processor on it, a microcontroller on it, 32-bit, of course, with flash and RAM all built into it. And you can program it using Python, in fact, using a variation of Python called CircuitPython. So what I want to look at today is how you use the Trinket M0 with CircuitPython. So if you want to find out more, please let me explain. So as you can see, this really is quite a small device. Hasn't got that many I/O pins on it. However, it's enough to get you started with some very simple circuits. So what we're looking at today is how you program the Trinket M0 using CircuitPython, and we'll build a few simple programs to kind of introduce you to the whole idea. Okay, let's get cracking. So we're going to be writing Python code to control the Trinket M0, and the easiest way to do that is to use the mu Python editor. It's a Python editor for beginner programmers, and it's a really easy way to write Python and get it to work with the Trinket 0. You need to go to the Code with Mu, code.mu website, and you need to download it from there. You need to pick the version that you want to download for Windows, 32-bit, 64-bit, for Mac OS 10 and so on. Download that and then start the installation program. The installation program is pretty normal. You just go through next, set the destination folder and so on, and it will unpack that and install it on your PC. The first time you run mu, you get a chance to set it up for different boards, CircuitPython, Microbit and so on. I've collected CircuitPython here so it knows how to work with the Trinket M0. So I've pushed the Trinket M0 into the breadboard. The pins on the bottom of the board go in very nicely there, and I've just simply connected up the power with the USB, and now we can download download a program that will flash the LED. So let's look at the program. Okay, so here we are inside of mu, and we're basically going to write a simple Python program. Now for this first example, I'm going to kind of type it out with you line by line. For the later examples, we're just going to very quickly do a bit of cut and pasting, and all of these code will be available on my GitHub. So first of all, you need to import some relevant libraries, because there are different things you need to be able to tell Python about. So we import board, which tells us about the Trinket. We're going to import digital I/O, and we're going to import time, and we import time because we need to do a delay later on. Now we're going to say LED. Well, that's pretty obvious what it is. There is a built-in LED on pin 15, and we're going to be using the digital I/O library, and we're going to say digital in out. That sets the fact that you wanted to set up a board as an input output, and we want to use the pin, and the pin is board.D13 because it's pin number 13. And then we need to tell it, well, which direction is this pin going? Is it an output or an input? So you say direction, and we say it's equal to digital.io.direction.output. So that's basically defined a LED, a variable called LED, which is connected to pin 13, and we've told it it's an output pin. That's pretty simple. Then we go into a Python while loop here. Okay, so we're saying while true, which means it will just keep on going round and round and round forever. We say LED.value is equal to true. That basically turns it on. Then we want to have a little bit of a pause, so we do time.sleep, and we want to sleep for half a second. Then we want to change the LED. Oh, look, I've got LED.veil. I've just noticed there it's value. Look at that. Sorry about that typing mistake there. LED.value. Okay, LED.value is now equal to false because we're turning it off. And then finally, we want another bit of a sleep, and we'll just again sleep for half a second, and that's it. So that's the whole program. defines some input, defines some libraries that we need about board and digital I/O, sets up a variable called a LED, and then inside this infinite loop, it basically turns it on, waits half a second, turns it off, waits half a second, turns it on, waits half a second, and just keeps on going round and round and round. Now, we need to save this file, so if we click save here, and we need to save it, as you can see, CircuitPython comes up as drive N, and we want it to be main.py, main.py. We'll say yes, and that automatically downloads it and reboots the board, and which means the LED should be now flashing. And now we can see here that the built-in LED there, red one, is flashing on and off. Okay, so now what we're going to do now is we are going to deliberately change something here on the program so that it's wrong. So here on line 12, we're going to misspell the word false. So it's got the wrong spelling there. Now, of course, this is an interactive program. It's Python. It uses an interpreter. There's no compiler. So when we now save this and try to run it, of course, Python's going to come up with an error. So let's see what happens. So as we can see, the red LED is not flashing, and this multicolored LED is doing some crazy stuff. Now, the first one is always green. That tells you the program is booting up. The next color is the error. In this case, it was white. If you notice that, here is green and then white. And then after that, it tells you the line number. So let's count it. Okay, so we see 1 flash and then 2 flashes. So that's actually the tens and the units. So 1 flash of 10 is 10 plus 2 flashes of blue. That makes it 12. So there's an error on line 12, and the white actually means it's a name error. So there's a name error on line 12, which is right because we've changed the name of the word false there, and we've given it with an extra E, and false is an unknown name. It doesn't know what it is, and so that's the error. So if we fix that, then it will go away. But there's another way of looking at it, and that's through the serial monitor. So let's go back to the mu editor and see what we can do with the serial monitor. If you go up here along these buttons, here's one called serial. If you click on that, it actually shows you the output that's coming out of the serial connection over the USB from the Trinket 0, and we've missed the error because we've hit it too late. But if we hit Control D now, as it says here, then it will reload the program. Let's do that. Okay, and there we go. Name error, as we saw from the code on line 12. False spelled incorrectly there is not defined. And of course we can just fix that and hit save. And now everything runs normally, and there is no output. There is the main.py output, nothing, because we're not actually writing anything to the output. However, of course, we could write something to the output. So let's just put in here, look, print, and then we're going to say the old classic, hello world. Okay, and so we've just basically called a line to print before the loop, so we're expecting it to come out once, and then the LED will start flashing. So again, let's just save that and watch the serial monitor at the bottom. There we go, hello world. So you can actually print out things during your program for debugging, for messaging. You can actually even interact with this, and you've got this serial monitor here on the inside the mu editor. So what I'm going to do now is quickly cut and paste in a slightly different program that controls the big LED, the RGB LED in the middle of the board there. So we start by importing time and board, and now a special Adafruit library that controls dot star. Now dot star is actually a strip of LEDs. You can get, those LED strips that you put, for decoration and for ambient lighting. But this is a special one on board that's actually only got one LED, the very first one. And so basically the way you set it up is like this. You just say LED is a dot star LED, and you define it here according to how the stuff on the board here needs it. You just need to just cut and paste this from my code or from the Adafruit website. We're going to set the brightness just to 0.4. It's a value between 0 and 1. And now we're going to the loop. It's very similar, except for rather than saying LED is true, LED is false, what we say is LED 0. Because remember, there's only one LED on this LED strip. And here is red, green, and blue. So what we're going to do is we're going to set red, wait half a second, set green, wait half a second, set blue, wait half a second, and then go round in a loop. And so if we save that now, we should see the big RGB LED on the board start flashing through those three colours. Okay, so now we're going to build a circuit which flashes an LED, an external LED. So we've got our Trinket 0 plugged into the breadboard here. And we're going to need a few wires. And what we're going to do is we're going to take this orange where it probably should be red, but it's orange. It's the only one I've got at hand. And we're going to take it from this USB pin, okay, which is the same as 5 volts that comes in through here on the USB, and we're going to connect it to the positive rail. So if you remember on these boards, this whole line here is now going to be positive, this whole line here will be ground, and the pins are connected across the board like this. So that's why this one here is connected to this pin here. And we're going to do the same with ground. There's a ground pin here on the Trinket, which is this second pin in here. And we're just going to connect that up to the ground like that. Okay, we're going to need an LED. And so what you do is, remember, on an LED, the longer leg always goes to the positive, the shorter leg goes to the ground. So we're just going to stick this in here in the ground, in the ground connected plane there, and stick that across onto the breadboard. And then we're also going to need a resistor, because if you power it up directly, it's just going to blow the resistor, blow the LED, sorry. So we're just going to put that across 2 connections here. It doesn't matter which 2, as long as it's obviously not connected to something here from the board. Obviously one leg, of course, of the resistor needs to go to the same line as the positive leg of the LED. And then the final thing we do is that we take pin number 2. We're going to use pin number 2 to turn on and off the LED. So that's pin number 2 there. And then we connect it to the same line as the resistor. So that's it all connected up. And now we need to put in the power. And then of course we've got a special program which we'll look at that will get that running. Okay, so the program for controlling the external LED is exactly the same as the one for controlling the internal LED, except for now we want to use pin 2, which is what we connected our LED through the resistor to. And so we change that from D13, make it D2, and that will now control the external LED rather than the internal one. And now for one final quick example program, the ARM processor here, the Cortex-M0 processor, actually has a temperature sensor into it, so you can read the sensor. So what I thought, we'd do a very simple program that changes the LED to be red or blue depending whether the temperature is going up or down. These first few lines are very similar to the program we've just done. Here we're actually reading the temperature. There you go, microcontroller.cpu.temperature, and we've also imported the microcontroller library here, the microcontroller in this case being the Cortex-M0 that's on the board, which is why it's different to the board library. And we set the previous temperature, so we have an initial temperature reading before we go into the loop, and then basically we read the current temperature, we work out the difference, the delta, there's D, which of course is T minus the previous T. We print it out and we'll look at that when it's running on the serial port. And basically we set the brightness to be whatever the difference is. And the reason we take the absolute value, of course, is it can be minus if the temperature is going one direction the other. So this gets rid of the minus, it's the absolute value. So if it was minus 0.1, it would just be 0.1. If it was 0.1, it's still just 0.1. And then basically if the difference is minus, less than 0, then we set it to be blue. It's getting colder. And if it's greater than 0, we say it's getting warmer. So we set it to red. We then get the new set the previous temperature to record it, sleep for 1 second, and go around and do it all again. So let's save that onto the board and watch it running. Okay, so now we have our temperature program running here. You can see when the temperature's gone down slightly, it's blue. When it goes up, it's red. And then the intensity of it tells you by how much. So even there a moment ago, it was actually off because it's a very small amount. And we can see it just changing red and blue as the temperature is being read there from the internal temperature sensor. And we can see the same output on the serial port. It will show us the difference and the new temperature. And that just is a little program to control the RGB LED there while reading the temperature from the CPU sensor. There we go. So it's first of all print out the difference and then the temperature. The difference between last time and the temperature, which is that print statement here that we had in the code. Print, there you go, print D and T. And so it's printing it out and controlling the LED at the same time. And there you have it, the Trinket M0 and CircuitPython. I really hope you found that useful. If you did, please tell me in the comments below if you'd like a follow-up video, maybe doing some more advanced stuff. and I'll see if there's enough interest to do that. Now, if you want to buy a Trinket M0, there are some affiliate links in the description below, and if you buy using those links, it does help out this channel. Okay, that's it. I'll see you in the next one.